So this one here, we have our graph, 1 over x, and we did this one before at a specific point, but now we're just going to generalize this point. Okay, so we're going to take some general point x, so the y-coordinate here is going to be 1 over x. Okay, and then we're going to take some point arbitrarily close, we're going to call that x plus h, and then we're going to end up with another coordinate here. I'm just going to draw it over here, 1 over x plus h. Okay, so that would be the y-coordinate of that point there. Okay, so we're going to take those points and we're going to take that red dot and we're going to bring it closer to the blue dot to evaluate the limit at x. Okay, so we need to set up our slope for this. Okay, and we're going to use a limit because we're going to move that plus h point. So we're going to let h go to 0. Okay, so it's going to be y1, so 1 over x plus h minus y2, which is 1 over x, and that's all over the run, which is going to be h. Okay, so again, this distance here is just going to end up being x plus h minus x, which is h. Okay, so I need to cancel this out. So if I put in 0, I get 1 over x minus 1 over x, which is 0 over 0. Yeah, I need to do some algebraic work on this. Okay, so as h goes to 0, I need a ratio to work with, so I'm going to make it a common denominator. So I'm going to end up with x minus x plus h all over the common denominator of x times x plus h. And that's going to be all divided by h, but I'm just going to make, instead of making a complex fraction, it's just divide h. It's going to just end up in the denominator of the fraction. Okay, so my numerator, I can see that the x and the minus x are going to cancel out. So I'm going to, in the top, be left with a minus h. So this becomes limit as h approaches 0. Okay, that's going to be negative h on top. And then we have our factor of h in the denominator. And that h is a problem h. This h here is not a problem because that's a plus 0. And plus 0s don't really affect anything. Here we have a times 0. We have, or divide 0. Here we have a times 0. Those can cancel out. Okay. When we cancel those out, we're left with 1. Anytime we cancel division or multiplication, we're left with 1. And so we end up with limit as h goes to 0. That becomes negative 1 over x times x plus h. That plus h being 0 is no longer a problem, so I'm going to evaluate my limit. I end up with x times x, which is negative 1 over x squared. Okay, so what I'm saying then is that this function, 1 over negative 1 over x squared, as I plug in x values in here, it will calculate slope values for that expression, for that function. Now, if we recall, in the last day, we actually calculated slope at x equals 1. We calculated slope to be negative 1. Well, if I plug in 1 here, yep, sure enough, I get a slope of negative 1. Okay, so if I'll just do that here. The slope at 1, okay, is equal to negative 1 over 1 squared, or negative 1. And that's what we calculated before. So that's a check. Now, if this is squared, that means that this denominator is always going to be positive. That means my slope is always negative. Is that really true? Is this slope negative for all values of x? Well, it's negative here, yeah, it's all negative. Negative here, yeah. Through that whole graph, every coordinate is going to give us a negative slope. Okay, it's always going to be sloping to the right, down to the right. Okay, so that formula seems to be the right formula for this graph. Okay, even here at -1, right? That should have parallel slope at +1. And yeah, if we put -1 into here, we're going to get the slope of -1. So this equation then seems perfectly reasonable that this is the formula that calculates slope, the equation that calculates slope. Okay, and we should be convinced because we found it using the slope formula. Well, if we found it using the slope formula, this thing must be calculating slope.